Hey guys, so we're going to talk a little bit about ionic bonding and lattice energy. So the first thing that we need to kind of talk about is the fact that when I ever hear the word lattice energy or electrostatic forces, I'm only talking about ionic compounds. And an ionic compound is a metal and a nonmetal that's coming together. So what I want to show you here is a couple of notes that you're going to put on the section. So first of all, crystal lattice is the structure that we give ionic compounds. A crystal lattice structure is closely packed, and I think that you guys saw like a picture of this in the other video, so that should be pretty straightforward. So whenever I have a metal and a nonmetal together, they're closely packed, they're in crystal lattice structure. And what's holding these things together is the electrostatic force or lattice energy. All right. And all you really need to know about that is that it's Coulomb's law. Okay. So Coulomb's law, is force of attraction, and that's equal to Q1 times Q2 over R squared. Now, Q1 and Q2 in this case is representing the charge of the ions. So for instance, if I have Na and Cl coming together, Na's charge is a +1, Cl's charge is a -1. So those are your charges of your ions. Now, the relationship between that and force of attraction, as the charge increase, then my force of attraction increases as well. Now, how does that relate to lattice energy? How does that relate to electrostatic forces? Well, if my force of attraction is increased, then my lattice energy increases as well. Now, that can relate to different properties of ionic bonds. We all know that ionic things have very high melting points. They have very high boiling points. But they have different strengths relative to one another. So how I know if one ionic compound has a greater melting point or boiling point than the other is all due to its lattice energy, its force of attraction. So, first thing, as charge of the ions increase, force of attraction increases as well. If that's the case, then that means that the lattice energy increases, and therefore that particular compound will have a higher melting or higher boiling point. So an example dealing with this is what I have over here. It's NaCl versus MgCl2. Now, this could be definitely a free response question where they might just say MgCl2 has a higher lattice energy than NaCl. And that's your statement. You have to justify just like you did for atomic structure and periodicity for that unit. They could say that MgCl2 has a higher melting point than NaCl, and you have to justify that. Well, the way that you justify is you're talking about this in a sequential form. So first you compare and contrast your two ionic compounds. So what's going on with this ionic compound is that Na has a +1 charge, Cl has a -1 charge, versus MgCl2. Mg has a 2+ charge, and Cl has a -1 charge. So how I compare and contrast those two is, well, both Na and Mg are bonded to Cl ionically. Sorry, it's an ionic bond, but NaCl has a +1 -1 charge, whereas MgCl2 has a +2 -1 charge. Now, whether it's positive or negative, that doesn't matter. What matters is like the absolute value. So you have +1 times -1, which is just 1, versus +2 times -1. So that's a positive or a 2 absolute value there. So as that number of the absolute value increases, that's what increases the force of attraction. So MgCl2 has a greater lattice energy than NaCl. And that is because if this charge increases, my force of attraction increases as well. And force of attraction and lattice energy have a directly proportional relationship. Now let's look at example 2. So I look at NaCl and I look at KCl as well. Well, NaCl is a +1 -1 relationship, And KCl also is a +1 -1 relationship. So if these two ionic compounds have the same charges, we then look at what is in the denominator of our force of attraction equation, and that is r squared. The r is representing your distance, your size, your radius, and we all learned this from the atomic structure unit. Well, because they have the same charge, we look at distance. The relationship is as size increases, our force of attraction decreases. And of course, if force of attraction decreases, then our lattice energy decreases as well. Our melting points and our boiling points will decrease as a result also. So I look at Na and I look at K because Cl is the same for both of them. Na versus K. K is further down on the periodic table. So that means since K has a bigger size, it has a smaller force of attraction. So out of these two, which one has the greater lattice energy? It's NaCl. NaCl has the greater lattice energy because it is smaller in size, even though they have the same charge. And because it's smaller in size, it has a greater force of attraction, which in turn gives it a greater lattice energy. So this is how we talk about ionic compounds. We relate them according to lattice energy, their charge versus their size. Okay, we look at charge first. If they have the same charge, then we look at size. We always look at charge first, though. And hopefully you guys will be able to put this in a justification question on the free response. They could also ask some multiple choice questions that says, like, which is more ionic? Whenever you see that term more ionic, that just means which has a greater lattice energy. So I hope this was helpful. I hope it recorded because it's been a while since I've done these videos, and I'll catch you later. Are you going to stop for me?